Okay, we're going to kick off and get started. Hi, everyone. Thank you so much for joining us today. As you know by now, my name is Shifa Kelleher. I am your partner technical lead based out of our Cork, Ireland office. And you are joining us for our NetApp on NetApp EMEA webinar, Scaling Object Storage for the Enterprise with StorageGRID. And joining us to talk on that topic today is Senior Storage Engineer Ken Lee. Just before we get started, just some quick housekeeping rules. You'll see we have a Q&A function, so please, if you have any questions or any comments, feel free to shoot them in there. Myself and Chris Long will be taking a look at these throughout the program, so Ken will have an opportunity to answer your questions. This meeting is also being recorded, and the recording will be available soon after today, so keep an eye out on your inbox for that. And yeah, that's it. Like I said, any questions, you can throw them into the chat or the Q&A. And you'll get an email anyways with the recording after. So if you have any questions afterwards that come in, just let us know and we can get those answers. So thank you very much for joining us today. And Ken Lee, I'll let you get started.
Okay. You guys could see my share?
Yeah, we can see your screen. Thanks, Ken.
Okay. Hi, everyone. My name is Ken Lee, and hopefully you guys can hear me clearly as I'm just getting over a cold in my voice. Hopefully that will make the hour mark. I'm a storage admin here at NetApp for over 14 years now. My main responsibility right now is StorageGRID. So I'm going to go over a little bit about the history of how we got here. And then I'm going to talk about two use cases that was big to us here at NetApp. So about 10 years ago, 2015, around that time frame, we started using StorageGRID, and we did so slowly, only using StorageGRID for static data, doing on-tap backups using net backup. Then we transitioned to AltaVault and started doing SOX compliance backup. When AltaVault was sunsetted, we kept the StorageGRID AltaVault environment because of the SOX retention period. After that, we slowly introduced S3 object store to the rest of NetApp IT. At the beginning, mostly for static content like Splunk, Git repository, and VM backups. So in today's environment, we currently have 3 storage grids. The first one being what we call our core storage grid. It is an internal storage grid that is not accessible by the outside. Originally, this was a 3-site storage grid, but now, after closing our Sunnyvale site, it became a 2-grid site. Their locations are in Hillsboro, Oregon, and the second one in RTP, North Carolina. Running version 11.7.0.11 with 67 nodes and a total capacity of 6 petabytes. 61 data nodes using the SG 5660, 5712, 5760, the 6060, and we are in the middle. Well, no longer in the middle. Last week, matter of fact, we decommissioned the 5660. We're running Centricity 11.8.0.1R3 using 2 VM admin nodes and 4 VM gateway nodes for load balancing. So the reason why we decommissioned the 5660 is because it's not supported at the higher version. I believe 11.8 no longer supports that hardware. Our second storage grid is our DMC environment, and this one is customer facing. It also started as a 3-grid site until Sunnyvale closed. It is running 11 11.7.0.11 has a total of 23 nodes doing 2 copies with 6 petabyte of capacity. There are 19 data nodes. Those are 5712 and the 6060. Running centricity 11.80.1R3 with 2 VMs for admin node. And we're using Avi, which is the VMware load balancer for the gateway nodes. Originally, we were using the F5 load balancer. We started an upgrade yesterday, and this environment is now at release 11.8. But, when you go to 11.8, one of the ports got moved. 18082 was moved to 18086. And because this is a DMZ, as it is facing our customers, our firewall team had to open that port before any traffic can be flowing through there. So just know that when you go into 11.8, there's a port change. Our third storage grid is our active IQ, what we call a bare metal grid. For the compute portion, we are using Cisco UCS, the C220M5, running Red Hat 9.4. It has 2 10 gig interface, 2 SAS ports for the E series, running Podman instead of Docker because Red Hat dropped support for the Docker engine. The backend E series is the E series 5760. We also have the SG6060 and the 6160. You might be wondering, those SGs are appliance and not bare metal. It is because we just added them less than a month ago. When we built this grid, the grid was a single site grid. Now it is a 2-site grid. This is a process that we're going to do is migrate everything out of the first site into the second site, running transity of 11.80.1R3. We are also using ONTAP for the UCS storage for the compute iSCSI bootruns. So the grid is running 11.9.03. Total number of nodes is 24. Because we started this grid as a single site, we are using eraser coding of 4+2 for any objects less than 200K. We do 3 copies locally. The grid has a capacity of 6 petabyte. Total number of storage nodes is 14. We have a VM, 2 VM admin nodes, 6 gateway nodes, and 1 external Avi load balancer gateway. I will go through the reason why we started with a bare metal storage grid and about the admin nodes that we have, why we have so many. Okay, so that's our environment. So it's not very different from real customer. We built a storage grid and we went very slow with static data. And then we evolved it from there. You notice that I never talk about fabric foo. And the reason why is because we're NetApp and we just cut the storage is pretty cheap for us. So we didn't want to add a layer in there. But, we always suggest to the customer, the best way to start on StorageGRID is usually for backups, which is static data, and fabric foo from your ONTAP environment. So next, I will talk about the use case. And the first one being secure file upload. The name could have changed by now. I'm not sure. So if you were here more than 10 years ago, I'm sure some of you are familiar with the site upload.netapp.com, where we were using Aspera to allow our customer to upload files to NetApp. It required that our customer download the browser plugin. At the time, it only supported Netscape. I know I'm dating myself, plugins, and that plugin allowed the web browser to load and run external application software. So that's how we were doing the uploads. At the time, the file size was limited to 4 gigabytes. So if the plugins were giving our customer upload problems, we just told them, hey, try FTP. And FTP was insecure and not very robust. So during that time frame, NetApp was under a lot of pressure from our customer to get a better handle on this issue. When a customer had an issue with ONTAP, they had to upload their core files so that our engineering could do analysis on them in order to troubleshoot the issues, which with large customer, they tend to have large core files and uploads would often fail. It got so bad that our customer's CEO would call our CEO and complain because their systems were down. So to address this issue, these were some of the requirements. It must support very large core files. As ONTAP was evolving, the core files started to grow, and at the same time, we were introducing CDOT. It was estimated that core files can grow up to 800 gigabit. The upload must be able to function in different regions closer to our customer to decrease the data transfer time. And when the upload fails, it will be able to restart and not start over from the beginning. We also needed to address the key issues with the legacy upload solution, like slow upload rate, less setup for our customer, like opening ports or downloading plugins to be able, at a minimum, upload 150 gigs. The architect that we came up with is the customer must be able to be verified. The initial plan was to have the customer enter a NetApp IT, but that changed to allow the customer to enter a case number. Because if you open a support call, you would have a case number. We don't want any client-side plugin, just using the browser and nothing else. The developers uses a well-known stack, S3 SDK, Angular, and Node.js. During the design phase, they up the file transfer size to 2 petabyte, use S3 API for security, must be able to use multi-part upload for restartability, be able to use pre-signed URL for added security, meaning that we create a pre-signed URL that will expire in 6 hours and allow for pause, resume, and cancel. The secure upload is an outside-facing application, and therefore, our security team wouldn't allow us access in our core network. But our core files that are uploaded had to go to our engineering domain. That was how the legacy system was. And we didn't want to make any changes to the backend part. So we used one of the StorageGRID platform service, Cloudmere, to replicate incoming objects from the DMC storage grid into our corp storage grid. And from there, the data flow to our engineering domain without any changes. What you are seeing on the screen is the original environment having 3 sites. Once we decommissioned the Sunnyvale site, the grid became a 2-site grid. Nothing else needed to change. Data flowing to engineering, the domain engineering still worked. So how did we get the data from StorageGRID to the engineering domain in a timely fashion once the core files is uploaded? We have 2 regions, one in the west and the other in the east. Our customer decide which region endpoints to upload their core files. Once the user enters the case number and the access is verified, a pre-signed URL is created to use S3 multi-part upload to upload the core files for speed and restartability. Once the file is uploaded into StorageGRID, we want to get it to the engineering domain as soon as possible. And to do that, we use another StorageGRID platform service, SNS, Simple Notification Service. What we did was we configured a bucket to send notification to AWS SNS service when an object has been uploaded. There is a program that subscribes to that AWS SNS service and will know right away that an object has been uploaded. The program will then log into the core storage grid and migrate the core file into the engineering domain. So there is very little lag time once the file is uploaded. So after the application went live, everything was great. We were happy. Our customers were happy, except for those that were not within the United States. So we deploy a new standalone site in EMEA and use Cloudmere to replicate the data to the core storage grid in the United States. From the application standpoint, only a small minor change was needed. They just needed to add software code that said that, hey, if you were in EMEA, the upload will use the EMEA endpoint and the data would be uploaded to the EMEA storage grid. At the same time, the data can also be processed within EMEA if needed, instead of coming all the way to the US. So why did we do the design this way? Why did we not just create a 3-site grid? Why we didn't just expand our current 2-site environment to a 3-site environment? Well, we looked at it, and what we concluded that if it was done, we would not, need Cloudmere, which is better, but we would run into problems with the data, right? The data itself would eventually get to the US because StorageGRID is an eventual consistency environment. But given our WAN pipe from the US to EMEA, which was very small, we felt that the storage internal communication, where each node within the cluster, that means all sites, all nodes, needed information about all the other nodes within the cluster. This chatter would be just too much for the WAN link that we had. We were not afraid of the data being transferred, but more on the queues for the internal communication getting too high, and over time causes issue with the grid itself. So also, we still had a problem. What if you're not within the 3 regions? Your uploads could still be very slow, you know. And after we rolled out the MIA site, after about 6 months, that location was scheduled to be shut down. So what was our solution? The solution was AWS S3. Since StorageGRID is S3 compliant with AWS S3, we can use AWS object storage instead of our own StorageGRID when it is outside of our region. All we have to do is open an account with AWS, deploy a very small AWS S3 object store, and point our applications to an AWS endpoint within that region. The only modification to our upload software is to add different AWS endpoint as a variable or a table entry. The user selects the region closest to them, usually outside the US. The file gets uploaded to AWS within that region, and then we use AWS S3 to replicate that object from outside the United States using AWS network backbone, right? We then use Cloud Sync to move the objects out of AWS S3 into our StorageGRID. We shut down EMEA, scaled the application to Sydney, Japan, Singapore, Hong Kong, and many other locations with no application code change, only variable or table regional data, and no need to deploy our own StorageGRID throughout the world. One thing to note, we do not leave our data in AWS. We only use AWS network to transfer data from outside the United States into NetApp. Once it reaches our StorageGRID, we remove any data in AWS. One is to comply with our data governance, and two is to keep AWS S3 storage usage as transient or almost nothing at all. This is the application front door. I'm sure many of you seen this before. So in summary, this applications use the following StorageGRID features. Multi-part upload to get fast upload speed. Platform service cloud mirror to move data from the DMC to our internal core StorageGRID. Platform service SNS to trigger notification when an object has been uploaded so that data can be acted upon as soon as possible and be moved to our engineering domain. Cloud Sync to transfer data from AWS S3 object store into our StorageGRID. Using these NetApp features allows the application to be flexible, scalable, and cost-effective. I will pause here to field any questions that you might have.
Yeah, hi Ken. I just actually have some questions. Thanks so far. It was a really interesting case study. You mentioned StorageGRID's platform services like Cloud Mirror and SNS. Can you explain how these help solve real business problems like speeding up for file delivery engineering?
Yeah, see, so, Cloud Mirror allows you to copy an object from one storage grid to another storage grid without any coding, right? So all you have to do is turn it on, and then um, you could use this to mirror to a secondary site. Let's say your customer wants the same data, and you don't want to do anything. You just want to create some rules in storage grid and say, hey, if this object is uploaded, I want my partners to have the same data. And then they won't even touch your environment at all. And Cloud Mirror will allow you to do that with minimal effort. You just need an endpoint from your partners. Or, even if you want to do a disaster recovery, um, or have data as a place where if you get an attack, uh, and everything's encrypted in StorageGRID or something, this data using Cloud Mirror would be safe, and you could bring it back.
So a lot more efficient and more safe at the same time.
Yes.
Brilliant. Thank you.
Okay, so if there is no other question, I'm
There's
going to
no current
start.
questions in the chat now.
Okay, I'm going to start on the second case. Okay, so this particular case is regarding our active IQ data lake. Okay, just to give you a feel for how large the system is, here is some metrics for active IQ. There are about 10 trillion data points per month of telemetric data. You can say that this is auto support, all the auto supports that NetApp gathers. That data is translated to about 3 petabyte of data lake information. Excuse me. And another 10 petabyte of shared storage that NetApp use internally. And for our customers, they can get to some of the data via Active IQ Digital Advisory, mobile apps, and custom APIs. The original data lake architecture is ingesting telemetric data into Hadoop environment using Kafka, streaming, and Apache Fume. We have many clusters where 4 compute servers are directly attached to one storage array. We have about 33 mini clusters. That came out to be about 4,000 plus cores and 7 plus petabytes of disk storage. Is huge. So this is the new data lake architect. The major change is to use Dremio in a Kubernetes environment, replacing the original Hadoop environment. And Hadoop was a bare metal environment, and it was more painful to manage versus a Kubernetes, in things like batching and that type of stuff. Apache Spark was still used for batch processing. The amount of disk space needed shrink quite a bit to 3 petabytes. We're using 16 Dremio executors. Those are nodes on a Kubernetes cluster. Data is stored in Parquet format. That's just what Dremio uses. And Dremio is able to use StorageGRID as the backend to house their archaic data. So originally, we had about 130 plus servers and have 4,000 plus cores. We wound down to about more than 60% reduction in compute. Even with that much reduction in compute, we got faster query time, 10 to 20 times improvement. With Hadoop, on average, queries to the data lake took 45 minutes. Today, with StorageGRID, the largest query took about, anybody want to guess? From 45 minutes to
Minute.
2.5 minutes.
Oh, I was going to say 5 minutes.
Yes. So that was for our largest queries. It took 2.5 minutes. So
Wow.
for our smaller queries, it takes seconds. So that's really, really big, right? And that's what StorageGRID is providing, is that speed for stretching. So we got about 30% total cost of saving using less compute, less data center space, and less storage space. We save about 2 petabytes of storage. This was a major change for us at NetApp. So, as I said earlier, why did we go bare metal instead of appliance for our AIQ system? It is because the Hadoop environment, we wanted to use the same E-series that we purchased a whole bunch of storage for them. So we were going to free that up during the migration. As a first phase, we took 7 E-series and start to build a single StorageGRID site, because this will be a single site, and to ensure data accessibility from a single node being down, and to keep the amount of space as low as possible, we decided to go with a ratio cooling of 4+2. Okay, so we couldn't take all the storage right away, right? We had to take pieces of it. So that's why we did it in phases. This allows us to do, with the 4+2 erase the code, allow us to do one storage node down. And if we had another node down, it shouldn't cause any problem because of 4+2. So for our data node, the compute is running on a UCSC 220M5 running Red Hat 9.4. Since Red Hat no longer support Docker engine, we're using Red Hat Podman engine instead. Nothing needs to change. All you do is create an alias for Docker commands when you do a setup for Red Hat. The physical host is mapped 1-to-1 to an E-series. The configuration is such that for the host bootLUN, it is attached to our ONTAP storage. That is just our NetApp IT standards. You could attach it to the E-series, but we didn't want to do that. The E-series has 2 LUNs that StorageGRID uses at the host level, with the rest of the LUNs, the data LUNs, only visible inside to the StorageGRID container. For the appliance, and to log into the OS, you would need to SSH into the StorageGRID no IP with a port number of 8022, okay? And use the same user ID admin. That's for appliance. For bare metal, there is an OS interface, just like any other Red Hat host. So to log into the host, it's a little different. You don't use the port 8022. You just go in like it was your own Red Hat environment. You do commands, and you will see Docker running in the background. And in that background, you will see StorageGRID running. So because of that, the host name is different from the node name. This is just what an appliance looks like to give you a comparison, right? As you can see, I stated earlier that SSH into the appliance OS would require you to add 8022, and all the required storage comes from the backend ECRs. There is no ONTAP, it's just our standards. Both the host OS and the container are running Debian. Other than these little minor changes, bare metal is pretty much the same appliance, same deployment. This concludes my presentation. We have any questions?
Yeah, thank you so much for your presentation, Ken. And just so everyone can see, you can connect to Ken on various different links here, email, LinkedIn, NetApp, YouTube channel. I actually have two questions from my own end, because I always find case studies fascinating, and the huge improvements you guys made in speed is mind-blowing, to be honest. Um, so when it comes to the previous case study for the Active IQ transformation, I know we talked a lot about the big improvements we found from that, but how difficult did you find the migration itself? Was there any like particular challenges that stood out?
That's okay. So when we went into this project, they allocated a lot of time for migrating, because the data was large. So
Yeah,
they were afraid that will be the biggest roadblock in terms of getting the project done. But it wasn't. It was very, very smooth. Talking to the project team and everything, they it just blew their mind that moving the data from the Hadoop environment to StorageGRID was pretty quick. It 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 it, it just it was so fast that it was just I can't have words for it. It was just so fast. So and 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 the speed after they moved the data when they were testing the query using Dremio, uh, that also blew their mind because before, to do analysis and stuff like that, they would have to wait 45 minutes to an hour just to get the data to start working on it and see what's going on. But now, with 2.5 minutes for the largest query, uh, they just they love it. Yeah, they just love it.
yeah, I'm sure we wish every project went that fast.
Yeah, yeah. And on that project, we're still evolving. Um, there's things going on,
Mm,
uh, site closures, and making it fail safe in terms of because Active IQ is very important to NetApp.
yeah,
So the next part right now that we're doing is migrating the data from HIO to RTP, and
okay.
because of where we're at since Active IQ went live, we have a lot more data now too. But with StorageGRID, all I have to do is change the ILM policy, and it will start moving the data for for us in the background from one site to the other without any effort from the application team.
That's fantastic. My second question also kind of stating the obvious, but I always like to ask, why leverage StorageGRID for ActiveIQ? Why not use some other on-top system?
Yeah, we they looked at that, and you know, um, object storage is meant for large amounts of data. Object store was built for, you know, Internet of Things, where all they do is stream lots and lots of data. Because our active IQ is mostly data points from our ASUP and all, all those data, it was just a perfect fit, right? And originally, when they did Hadoop, Hadoop was the greatest thing at the time, right? And then over time, it just couldn't keep up. But with StorageGRID, like I said earlier, um, to get customer to be familiar with StorageGRID, I would always start off with static data. You know, every customer has some kind of backup. They should just start writing to StorageGRID to get a feel of static data, right? And you can start small. You don't have to start, very fast. And then when you have StorageGRID in the environment, then you could say, hey, you have ONTAP, why don't you do Fabric Glue, right? You already have both environments. And then from there, open it up to more transactional, applications like JFrog or other things like that, and then grow it, right? So our storage grid is built on Cassandra. So the backend is Cassandra. Cassandra will let you scale to hundreds and hundreds of nodes with minimal effort. And that will allow you to scale along with the amount of data growth that you have in the easiest, most efficient way. That's one of the reasons why we want to use StorageGRID for everything that has lots and lots of static and data. I also know that as we move along with technology, our storage is becoming faster, with SSDs and so on. So we are also starting to use it for transactional data. But using it for transactional data, people still think about um, snapshots for recovery. Well, StorageGRID doesn't have those type of stuff, but we might have in the future. So we're going in the right direction.
Yeah, exciting times lay ahead.
Yep.
Yeah. So that's it for today. I don't see any more questions in the chat, so we'll wrap it up here. But thank you very much for everyone for joining, and thank you very much, Ken, for presenting. I know you're sick. Yeah, so it's all been recorded, so you guys should get an email in the next few days with that recording. And like I said earlier, if you have any follow-up questions that come to mind, you can shoot me an email, and I'll get those answered. So that's it. Then I will say goodbye, and I hope you have a good morning, evening, wherever you are. Thank you.